Welcome back to our channel. Today, we are diving deep into one of the most mysterious and mind-bending phenomena in the universe, black holes. From their formation to their role in popular culture, black holes are a topic that has fascinated scientists and the public alike. So, let's unravel the enigma of black holes together. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape from it. The boundary of a black hole is called the event horizon, the point of no return. Predicted by Einstein's theory of general relativity, black holes are formed when a massive object deforms spacetime to such an extent that a black hole is created. Black holes can form in a few different ways, primarily from the remnants of massive stars that collapse under their own gravity at the end of their life cycles. There are three main types of black holes. Stellar black holes. These form when a massive star collapses after exhausting its nuclear fuel. They typically have masses ranging from a few to several tens of solar masses. Supermassive black holes, found at the centers of most galaxies, including our own Milky Way. These black holes can have masses ranging from millions to billions of solar masses. How they form is still a topic of active research, but they might originate from the merging of smaller black holes or the collapse of massive gas clouds. Intermediate mass black holes, hypothesized to exist with masses between stellar and supermassive black holes, their existence is still under investigation. Black holes are defined by three main properties: mass, charge, and angular momentum. The event horizon is the defining boundary beyond which nothing can escape. At the heart of the black hole lies the singularity, a point where the curvature of spacetime becomes infinite, and the laws of physics as we know them break down. In 1974, physicist Stephen Hawking proposed that black holes aren't entirely black but emit radiation due to quantum effects near the event horizon. This radiation, known as Hawking radiation, causes black holes to lose mass over time, potentially leading to their evaporation in the distant future. Although we can't observe black holes directly, their presence can be inferred through their interactions with surrounding matter and their gravitational effects. Observational evidence includes accretion disks. Matter falling into a black hole forms an accretion disk that heats up and emits X-rays and other radiation. Gravitational lensing. The intense gravity of a black hole can bend light from objects behind it, creating a lensing effect. Stellar orbits. The motion of stars orbiting an invisible massive object can indicate the presence of a black hole. The concept of objects with gravitational fields too strong for light to escape dates back to the 18th century, with ideas proposed by Jean Michel and Pierre-Simon Laplace. However, our modern understanding of black holes began in 1916 when Carl Schwarzschild provided the first solution to Einstein's field equations, describing what we now call a black hole. The term black hole was coined by physicist John Archibald Wheeler in the 1960s. Black holes have captured the public's imagination and are frequently depicted in science fiction as portals to other dimensions or as destructive forces. Films like Interstellar and books like Stephen Hawking's A Brief History of Time have helped popularize the concept of black holes, making them a staple of popular culture. Research on black holes is ongoing, and recent discoveries have been groundbreaking. In 2019, the Event Horizon Telescope collaboration captured the first direct image of a black hole's event horizon in the galaxy M87. This image provided visual confirmation of black holes and offered new insights into their properties. Black holes remain one of the most mysterious and intriguing objects in the universe. They challenge our understanding of physics and continue to be a major focus of astronomical research. As our technology advances, we'll undoubtedly uncover even more about these enigmatic entities and their role in the cosmos. Thanks for watching. If you enjoyed this video, make sure to hit the like button and subscribe for more explorations into the wonders of the universe.
Have you ever heard of ghost particles? They're called neutrinos, mysterious particles that pass through us in unimaginable numbers every second without leaving a trace. And new research suggests these ghost particles might be coming from an unexpected and powerful source: supermassive black holes. In today's video, we dive deep into the latest findings on how blazars, a type of active galaxy, could be bombarding Earth with these elusive particles. At the center of most galaxies, including our own, sits a supermassive black hole. When these black holes actively feed on surrounding material, they create what's known as an active galactic nucleus, or AGN. But some of these AGNs take it a step further, shooting out powerful jets of radiation and matter at nearly the speed of light. When one of these jets is pointed directly at Earth, we call it a blazar. Blazars are like cosmic cannons, aiming straight at us. And these intense jets could be creating neutrinos, strange particles that are almost impossible to detect. Neutrinos have no charge, almost no mass, and can pass through planets, stars, and even humans without leaving a mark. In fact, 65 billion neutrinos pass through every square inch of your body, every single second. That's why they're often referred to as ghost particles. But why are they important? Neutrinos can pass through dense cosmic objects that even light can't penetrate, making them valuable tools for probing the universe. So, how do these blazars create neutrinos? It all comes down to gamma rays. Blazars are a subclass of AGNs, and they emit highly energetic particles known as cosmic rays. When these cosmic rays collide with photons, or particles of light, they can produce neutrinos. Gamma ray flares from blazars have long been suspected of being the source of the neutrinos we detect on Earth. The link between blazars and neutrinos was first hinted at in 2017 when a high-energy neutrino detected by the IceCube Neutrino Observatory, buried deep in the ice of Antarctica, was traced back to a blazar named TXS0506+056, located 5.7 billion light-years away. This was a major breakthrough. It showed that the flares of these blazars could be the source of high-energy neutrinos. But the full relationship between the amount of neutrinos, known as the neutrino flux, and the blazar flares remained a mystery, until now. An international team of researchers decided to dig deeper. They analyzed TXS0506+056 and 144 other blazars from the Fermi Large Area Telescope monitored source list. They focused on how often these blazars enter a state of intense gamma-ray flaring. This was called the flare duty cycle. The flare duty cycle essentially shows how much time a blazar spends in a flaring state and how much of its total energy output comes from these periods. The researchers found something surprising. Blazars with lower flare duty cycles and lower energy fractions are more common. They exhibit a pattern called a power law relationship, where a change in one variable proportionally affects another. By understanding these patterns, scientists were able to make better predictions about how many neutrinos each blazar produces and when. They compared these predictions with actual neutrino detections from IceCube over short and long periods, helping them set upper limits on how much these gamma-ray flares contribute to the neutrino flux. These findings are just the beginning. With more precise measurements and new methods, we can refine our understanding of how much blazars contribute to the overall neutrino population in our universe. This could have huge implications for our understanding of the cosmos and the extreme processes happening around supermassive black holes. Future telescopes and observatories, both on Earth and in space, could provide even more data, helping scientists unlock the secrets of these powerful cosmic phenomena. The hope is that by studying blazars more closely, we can solve the mystery of the origin of astrophysical neutrinos. So what does all this mean for us here on Earth? While neutrinos from blazars pose no threat, they do offer a unique window into the most extreme environments in the universe. The research into these ghost particles will help us understand the most powerful engines in the cosmos, supermassive black holes, and how they shape the galaxies around them. What other cosmic secrets are waiting to be unraveled? Stay tuned and keep watching to find out. 5 amazing facts about Europa, Jupiter's mysterious moon. Fact 1. Beneath its icy crust, Europa hides a vast ocean of liquid water, possibly double the volume of all Earth's oceans combined. Fact 2. The surface is made of ice, with huge cracks and ridges hinting at active geological processes below. Fact 3. With liquid water, essential chemicals and heat from tidal forces, Europa is a top candidate for life beyond Earth. Fact 4. Europa has water plumes shooting up from its surface, giving us clues about its mysterious ocean beneath. Fact 5. Powerful gravitational forces from Jupiter cause intense tidal heating on Europa, keeping its ocean liquid and dynamic. Could Europa be the next place we find life? Subscribe and stay tuned for more space discoveries. Europa, Jupiter's icy moon, is not just about oceans and ice. Here are 5 surprising facts about its extreme environment. Fact 6. Europa has a weak magnetic field, interacting with Jupiter's powerful magnetosphere. Fact 7. Its atmosphere is incredibly thin, made mostly of oxygen, not breathable for humans. Fact 8. Europa is bathed in radiation from Jupiter, making it highly dangerous for humans. Fact 9. Its surface is frigid, with temperatures dropping to -160°C. Fact 10. NASA's Europa Clipper mission is coming soon to uncover more secrets. How many more secrets does Europa hold? Follow us for more cosmic discoveries.
Black holes. They are the most mysterious and powerful objects in the universe, capable of bending space-time and swallowing entire stars. But could we one day use these cosmic giants as a source of energy? In today's video, we explore groundbreaking research that suggests humans might harness the immense power of black holes as a cosmic battery. Black holes are formed from the remnants of massive stars that collapse under their own gravity, creating a region where the gravitational pull is so strong that not even light can escape. Their immense gravity creates an event horizon, a point of no return. Beyond this, nothing, not even radiation, can escape. But what if we could tap into this incredible energy? A recent study conducted by researchers has proposed 2 fascinating ways to use black holes as cosmic batteries. Let's dive into these mind-bending concepts. The first method involves charging a black hole. Imagine injecting a black hole with massive, electrically charged particles. As these particles are sucked into the black hole, they would eventually create an electric field so strong that it would repel any further charges. When this repulsion equals or exceeds the gravitational pull of the black hole, it would be considered fully charged. At this point, the black hole would act like a giant cosmic battery, storing energy in its electric field. Einstein's famous equation tells us that mass and energy are equivalent. Thus, the mass of the charged particles contributes to the energy stored in the black hole. Researchers calculated that this process could transform about 25% of the input mass into usable energy, making this black hole battery about 250 times more efficient than a nuclear bomb. Now let's talk about extracting that stored energy. The first method involves a process known as superradiance. A rotating black hole's intense gravitational field drags space-time around with it. If gravitational or electromagnetic waves enter this spinning region but don't cross the event horizon, they can be flung back with even more energy than they originally carried. This deflection of waves converts the black hole's rotational energy into usable energy. In theory, this method could help us harness the rotational power of a black hole, giving us access to an almost unlimited energy source. Did you know that a strange blob of gas is circling the supermassive black hole at the center of our Milky Way, Sagittarius A star, at 30% the speed of light? Every 76 minutes, this blob sends powerful gamma-ray radiation towards Earth. What could be causing these high-energy pulses? Could this reveal new secrets about black holes? If you're intrigued, watch our full video for a deep dive into this cosmic mystery and uncover the science behind these strange phenomena.
4.5 billion years ago, Mars was born in chaos, a fiery molten world spinning rapidly. Volcanic eruptions, flowing lava, and no chance for life. It was a planet in turmoil. Fast forward to 3.8 billion years ago, Mars cooled down. Evidence suggests it was once covered by oceans, with rivers and lakes dotting its surface. But as it lost its magnetic field, the atmosphere thinned and water evaporated into space. Mars turned cold and the chance for life diminished. Today, Mars is a dry, dusty desert with a thin atmosphere. Dust storms rage and temperatures drop below freezing. Could there still be life underground? We don't know for sure, but the surface seems dead. What about the future? In 100 years, humans could set foot on Mars, releasing bacteria to produce oxygen. This could be the first step in transforming Mars into a more habitable planet. Fast forward 10,000 years. Mars might start to warm up with melting ice and emerging water. With human help, it could become a greener world filled with life. In 100,000 years, Mars could look like a second Earth, oceans, forests, and a thick atmosphere. But it's still a huge challenge. Will Mars become humanity's next home? Welcome to our journey through time to explore the evolution of Mars, a planet that has intrigued scientists, space enthusiasts, and dreamers alike. From its fiery beginnings 4.5 billion years ago to the possibilities for its future, join us as we uncover the mysteries of the red planet. How has Mars changed over the eons, and what could its future hold? Let's find out. Our story begins 4.5 billion years ago. In the early days of the solar system, chaos reigned as planets were forming from dust, gas, and debris. Amid this cosmic dance, Mars was born. The planet was young, hot, and spinning rapidly. With its molten surface and high-energy state, Mars was a fiery, uninhabitable world with no signs of life. At this stage, the surface of Mars was covered with molten lava, and the landscape was cracked and unstable. It was a harsh environment filled with volcanic activity and intense heat. Not a place you would imagine life to exist. Fast forward to 3.8 billion years ago, and things start to get interesting. Mars was undergoing significant changes. As its molten core began to cool, a new chapter opened for the red planet. Surprisingly, around this time, life was beginning to emerge on Earth, and evidence suggests that Mars might not have been so different. Research from NASA indicates that Mars was once covered by a vast ocean, covering about 1/5 of its surface. Imagine a Mars with rivers, lakes, and maybe even rain, a far cry from the dry and dusty desert we see today. However, this watery world didn't last forever. As Mars lost its magnetic field, it started losing its atmosphere. Solar winds stripped away the protective layer, allowing water vapor to escape into space. Scientists estimate that Mars lost about 87% of its water this way. What remained was stored as ice at the polar caps, the last remnants of a once more habitable world. As we move further along Mars' timeline, we come to a period between 2.1 billion and 400,000 years ago. This era marks the Martian Ice Age, a time when Mars became a cold, barren, and inhospitable planet. Mars became increasingly cold, and its once flowing rivers and oceans froze into massive ice sheets. Scientists have discovered evidence of these ice ages through data collected by NASA's Mars Global Surveyor and Mars Odyssey missions. These studies show that changes in Mars' orbit and tilt caused its poles to heat up, triggering a release of water vapor and dust into the atmosphere. These particles would then settle at around 30 degrees latitude, forming layers of ice and dust. Despite these dramatic climate changes, Mars' environment became more like a frozen desert. Any hopes for life on the surface faded, and Mars became a dead planet, or so it seemed. Today, Mars is a cold, barren desert with a thin atmosphere composed mostly of carbon dioxide. Its surface is covered with iron oxide, giving it that signature reddish hue. During the day, the sky appears pink due to dust particles suspended in the atmosphere, but at sunset and sunrise, it turns a striking shade of blue. We have sent numerous missions to explore this desolate world, from the Viking landers to the recent Perseverance rover. Yet we still wonder, is there any life hiding beneath its surface? Some scientists believe there could be microbial life lurking underground, protected from the harsh surface conditions. But as of now, the red planet remains largely silent. So what does the future hold for Mars? Let's leap forward 100 years. Humans have finally set foot on the red planet, a dream that has fueled our imagination for generations. This marks the beginning of humanity's greatest adventure, the colonization and possible transformation of Mars. The first step, introducing specially engineered bacteria that can survive and thrive in Mars's harsh environment. These bacteria would consume carbon dioxide from the atmosphere and produce oxygen, slowly transforming the planet's atmosphere over time. It's a small but significant step towards making Mars more Earth-like. Fast forward another 1,000 to 10,000 years. Mars is undergoing a slow but profound transformation. The bacteria released by the first settlers have spread across the planet, and other methods to warm the planet, like deploying large mirrors to reflect sunlight, have started to pay off. As the ice begins to melt, more water is released, and Mars's atmosphere thickens. The increased water vapor helps trap heat, raising the planet's temperature. We start seeing signs of a green Mars, perhaps the first stages of a fully terraformed world. Yet this process is still far from complete. Now, let's take a giant leap into the distant future, 100,000 years from today. Imagine a Mars covered with lush forests, flowing rivers, and vast oceans. The atmosphere is now thick enough to support not just microbial life, but perhaps even plants and animals. It is a sight to behold. Mars has become a vibrant green world, potentially a new home for humanity. But even with all our advancements, transforming Mars completely to mirror Earth remains an enormous challenge. Could Mars become our second home, or will it remain a distant outpost, a testament to human ingenuity and exploration? The evolution of Mars is a story of fire, ice, and endless possibilities. As we continue to explore and learn, we realize that the future of Mars is not just written in the stars, but in our hands. Whether Mars will one day be a thriving world or remain a barren landscape, one thing is certain: our journey to Mars is just beginning. When you look up at the night sky, it seems like we understand a lot about the universe. We see stars, galaxies, planets. But did you know that everything we see makes up only about 15% of all the matter in the universe? The rest is something we can't see, an invisible, mysterious substance known as dark matter. And what if I told you that tiny, microscopic black holes might hold the key to unlocking this cosmic mystery? For every kilogram of matter that you can see, from your phone to distant stars, there are about 5 kilograms of dark matter hiding in the shadows. Dark matter doesn't emit light or energy, making it impossible to observe directly. Yet, its gravitational pull influences the movement of stars and galaxies, suggesting it must be there. Enter Stephen Hawking. In 1974, the legendary physicist proposed a bold idea. What if dark matter is actually made up of black holes? Not the massive black holes formed by collapsing stars, but microscopic primordial black holes that formed in the first moments after the Big Bang. These tiny black holes, he theorized, could be scattered throughout the universe, explaining the elusive dark matter we've been searching for. Primordial black holes would have formed in the first quintillionth of a second after the Big Bang. Unlike the colossal black holes we think of today, these would have been minuscule, but incredibly dense, perhaps packing the mass of an asteroid into the size of an atom. Imagine the incredible gravitational pull these tiny, invisible objects would have. Fast forward to today, and a team from the Massachusetts Institute of Technology, MIT, has taken Hawking's idea even further. Professor David Kaiser and his graduate student Elba Alonso Monsalve have uncovered evidence that suggests these primordial black holes could possess an unexpected characteristic, something called color charge. In the realm of particle physics, color charge refers to a property carried by quarks, the fundamental particles that make up protons and neutrons. Soon after the Big Bang, the universe was an extremely hot soup of quarks and gluons. As the universe cooled, these particles combined to form the nuclei of atoms. But during that initial hot phase, any black holes forming could have captured these quarks and gluons along with their color charge. Kaiser and Alonso Monsalve realized that black holes forming in this environment could end up supercharged, containing the maximum color charge allowed by the laws of physics. These supercharged black holes, unlike anything we've ever seen, would have been an entirely new state of matter, though they would have evaporated almost instantly after their formation. But even if they existed for just fractions of a second, these supercharged microscopic black holes could have left behind unique imprints on the universe. They could have influenced how the first atomic nuclei formed, a crucial moment in cosmic history occurring just 1 second after the Big Bang. By disturbing the equilibrium conditions during this critical phase, these black holes might have left behind subtle signals detectable by astronomers today. So, what are these signals we might be able to detect? They could be tiny deviations in the abundance of certain elements, or even shifts in the cosmic microwave background, the faint afterglow of the Big Bang that permeates the universe. By studying these signals, we can learn a lot about the early universe's physics and potentially even confirm whether primordial black holes could account for all dark matter. This is an exciting frontier in cosmology. Traditionally, scientists have explored a range of dark matter candidates, like weakly interacting massive particles, WIMPs, or axions. But the idea that dark matter might be composed of microscopic black holes offers a new perspective, a way to connect quantum physics with the large-scale structure of the universe. Dark matter is crucial for explaining how galaxies form and evolve. Without it, the stars and gas in galaxies would have spread out far more than they have. But if primordial black holes, formed in the chaotic aftermath of the Big Bang, are the answer, then our entire understanding of the universe's structure could shift. Imagine the implications. If all dark matter in the universe is made up of these microscopic black holes, it would not only solve one of the biggest mysteries in modern science, but also open up new questions about the very fabric of reality. Researchers around the world are racing to test this theory, using powerful telescopes and new experiments designed to look for the unique signals left behind by these tiny, ancient black holes. The quest to understand dark matter isn't just about solving a cosmic puzzle. It's about understanding the universe at its most fundamental level. The cosmos is full of mysteries, waiting to be uncovered. As we learn more about the universe, we uncover new layers of complexity and beauty hidden within the fabric of reality. Stay tuned for more deep dives into the wonders of space, and don't forget to subscribe, like, and share to join us on this journey through the stars. Deep in the vastness of the universe lies a cosmic wonder known as the ghost of Jupiter. But what is this mysterious object, and why does it carry such a haunting name? Meet NGC 3242, also known as the ghost of Jupiter, the I Nebula, or Caldwell 59. This celestial object is a planetary nebula located in the constellation Hydra. Discovered by astronomer William Herschel on February 7, 1785, and later observed from the Cape of Good Hope in South Africa in the 1830s, this nebula has captivated stargazers for centuries. So, why the eerie nickname, Ghost of Jupiter? It's because this nebula's round shape resembles the planet Jupiter. To some, it also appears like a ghostly eye staring back at you from deep space. Imagine looking through a telescope and seeing a pale blue, otherworldly eye in the night sky. It's no wonder that NGC 3242 has earned multiple names, each reflecting its unique appearance. Some call it the I Nebula because it looks like a giant cosmic eye floating among the stars. This nebula stretches about 2 light-years across from end to end. That's almost 12 trillion miles. At its core is a white dwarf star with an apparent magnitude of 11. This dying star is what remains after it shed its outer layers, creating the beautiful structure we see today. The inner layers of the nebula are believed to have formed around 1,500 years ago, and on both ends of NGC 3242, you'll find what astronomers call flyers, fast low ionization emission regions. These are lobes of rapidly moving gas that often appear red in false color images, giving the nebula its distinct dynamic look. NGC 3242 is a favorite among amateur astronomers. It can be easily seen through a backyard telescope. Most observers describe it as having a soft blue-green hue, but with larger telescopes, you can even make out its outer halo. For those with powerful telescopes, the ghost of Jupiter transforms from a faint blue dot into a detailed and mesmerizing celestial object, with layers upon layers of cosmic history on display. At the heart of this nebula lies a unique and fascinating star, a hot, bluish-white O-type star. O-type stars are some of the hottest and most massive stars in the universe, burning with a fierce intensity. In the case of NGC 3242, this central star has a spectral type of OH, indicating its specific characteristics within the O-type classification system used by astronomers. This star is what gives the nebula its glow, as its powerful ultraviolet radiation causes the surrounding gas to ionize and emit light. The result? A ghostly spectacle that we can admire from Earth. NGC 3242, the ghost of Jupiter, is more than just a cosmic curiosity. It's a reminder of the beauty and mystery of our universe. A dying star, shedding its layers, creating a vision that can only be described as out of this world. So, the next time you look up at the night sky, remember that among the stars, there are ghosts, silent witnesses to the universe's endless evolution.
How dark is the universe? This question has puzzled scientists for decades, and finally, NASA's New Horizons spacecraft has provided an answer. Astronomers have long wondered just how much light is out there in the vast, dark expanses of space. We know about the stars, galaxies, and other luminous objects, but what about the light that isn't immediately visible? Enter New Horizons, a spacecraft that has ventured farther than any before it. Launched over 18 years ago, it's now more than 5.4 billion miles from Earth. This distant location offers the darkest skies ever observed by a human-made object, making it the perfect tool to measure the universe's total light. Why is this important? The total amount of light in the universe, known as the cosmic optical background or COB, is a critical component of understanding the cosmos. Measuring COB helps us add up all the light from galaxies across the universe's lifetime. It's a way to glimpse the universe's history. Measuring light from deep space isn't easy. From Earth, sunlight and interplanetary dust obscure these faint signals. But New Horizons, far from the sun, faces no such issues. Its long-range reconnaissance imager, or LORRI, has a clear view. In the summer of 2023, New Horizons used LORRI to scan the universe. The data was clear: most of the light we see originates from galaxies. And importantly, there was no significant light from unknown sources. This discovery is groundbreaking. It confirms that the majority of visible light is from galaxies, solving a mystery that has baffled scientists for decades. This finding supports the idea that our universe, although vast and mysterious, is comprehensible and measurable. New Horizons has already changed our understanding of the solar system, with its historic flybys of Pluto and Arrokoth. Now, it's contributing to astrophysics, helping us see just how dark, and how bright, the universe truly is. As New Horizons continues its journey into interstellar space, who knows what other secrets it will uncover? One thing is certain, this mission is far from over. Stay tuned to our channel as we continue to explore the cosmos, one discovery at a time. Don't forget to like, share, and subscribe. Thanks for watching. Let us know in the comments what you think about New Horizons' latest discovery.
Did you know Saturn's iconic rings are about to disappear? Well, kind of. In March 2025, Saturn's rings will vanish from view, at least from Earth. Let's explore why this is happening. Saturn's rings will appear to disappear because the planet will be tilted edge-on to us. This happens only once every 29.5 years, so it's a rare cosmic event. The rings are made up of ice, rocks, and dust. Imagine chunks ranging from the size of a grain of sand to the size of a school bus, all orbiting Saturn. Saturn has over 145 moons. Titan has lakes and a thick atmosphere, while Enceladus might even have life in its hidden oceans. Cassini gave us stunning views of Saturn and its rings, revealing secrets about its moons and even geysers shooting organic material from Enceladus. Don't miss Saturn's ring disappearance in 2025. Subscribe for more cosmic wonders. Saturn's rings, the most iconic celestial feature in our solar system, are about to vanish from view. But don't worry, it's only temporary. In March 2025, Saturn's rings will disappear, and it's all because of a cosmic alignment that happens only once every 29.5 years. Saturn has fascinated us for centuries. In the 17th century, Galileo Galilei first glimpsed Saturn with his primitive telescope and described it as having ears, due to the limitations of his optics. Since then, we've come a long way in understanding Saturn's wonders, thanks to modern-day astronomers like Dr. Lucy Jones from the Harvard-Smithsonian Center for Astrophysics. So what's going on? Saturn's rings are disappearing because of the unique tilt of its axis. In March 2025, Saturn will be tilted in such a way that the rings will be edge-on from our viewpoint on Earth. This will make them almost invisible, only to reappear later that year in November. It's a cosmic game of hide and seek. Saturn's rings are made up of countless particles of ice, rock, and dust, ranging in size from tiny grains to massive chunks as big as houses. The rings are divided into several sections, including the A, B, and C rings, separated by gaps like the famous Cassini division, shaped by Saturn's many moons. But how did Saturn get its rings? One theory suggests they could be remnants of a moon or comet that was torn apart by Saturn's strong gravity. Others propose they are leftovers from when Saturn itself formed over 4 billion years ago. Each theory provides a fascinating glimpse into the potential origins of these majestic rings. Our understanding of Saturn and its rings took a giant leap forward with the Cassini-Huygens mission. This collaborative mission between NASA, ESA, and ASI explored Saturn for 13 years, revealing incredible details about the gaps in the rings, the influence of Saturn's moons, and even the possibility of subsurface oceans on moons like Enceladus. Saturn isn't just about rings. It has at least 145 moons, each with unique characteristics. Titan, the second largest moon in the solar system, has a thick atmosphere and possibly liquid lakes. Meanwhile, Enceladus might harbor life in its subsurface oceans, discovered thanks to water vapor geysers shooting organic materials into space. Upcoming missions, like NASA's Dragonfly to Titan, aim to explore these moons further, searching for signs of life and unraveling more secrets of Saturn's complex system. The search for life on Saturn's moons is just beginning. Don't miss this rare event in March 2025 when Saturn's rings vanish from view. Grab your telescopes and witness this incredible celestial event. And while you're at it, make sure to subscribe for more cosmic wonders and deep dives into the mysteries of our universe. SETI's hunt for alien life, exploring uncharted frequencies. Imagine a search that spans over 1,300 galaxies, diving deep into unexplored radio frequencies in the quest for extraterrestrial signals. That's exactly what researchers Chenoa Tremblay and Stephen Tingay have embarked on with the Murchison Wide Field Array, MWA, in Australia. Unlike traditional SETI searches that focus on higher frequencies, this study explored low radio frequencies between 80 to 300 megahertz, a range mostly untouched in the search for alien life. The idea is simple. The lower frequency range might hold secrets that higher frequencies don't reveal. Why not expand our search criteria to make sure we aren't missing something? Tremblay and Tingay zoomed in on a specific patch of the sky in the constellation of Vela, focusing on galaxies whose distances were already well measured. This targeted approach allowed them to estimate the power needed for a potential alien transmitter to send a signal our way. The result? No signs of alien life. But don't be disheartened. These findings aren't a dead end. Instead, they help fine-tune our expectations. For instance, it's estimated that a transmitter would need to output around 7 by 10 to 22 watts at 100 megahertz for us to detect it. That's an immense amount of energy. For comparison, a Type 2 civilization on the Kardashev scale would need the energy of an entire star to reach such power levels. But what if the signals are out there, just not in the form we expect? What if these advanced civilizations, if they exist, are using different methods, like lasers, or communicating at higher frequencies? Or maybe their radio beacons were temporarily turned off or pointed elsewhere when we were listening. There have been other searches as well. The Glimpsing Heat from Alien Technologies project used NASA's Wide Field Infrared Survey Telescope, WISE, to look for civilizations that might have constructed megastructures, like Dyson swarms, around stars. But again, nothing was found. Michael Garrett and Andrew Simeon's search of background galaxies also helped place limits on how powerful a detectable signal would need to be, refining our understanding of where to look next. What's clear is that our current technology and search strategies are just scratching the surface. There are potentially trillions of galaxies in the observable universe, and we've only examined a tiny fraction. As Tremblay and Tingay point out, several powerful radio emitters on Earth operate at these lower frequencies. So it's possible that similar signals could exist elsewhere in the cosmos. The road ahead for SETI involves expanding our search across multiple frequencies and approaches. It's not just about looking at the skies, it's about listening in new ways, being open to the unexpected, and pushing the boundaries of what we know. SETI's journey continues. Stay tuned. With a call to action, subscribe for more updates on the quest for extraterrestrial life.
Did you know that a strange blob of gas is circling the supermassive black hole at the center of our Milky Way, Sagittarius A star, at 30% the speed of light? Every 76 minutes, this blob sends powerful gamma-ray radiation towards Earth. What could be causing these high-energy pulses? Could this reveal new secrets about black holes? If you're intrigued, watch our full video for a deep dive into this cosmic mystery and uncover the science behind these strange phenomena.
Microscopic black holes, the key to dark matter. Did you know that for every kilogram of visible matter, there are 5 kilograms of dark matter we can't see? Some scientists now believe this mystery could be explained by microscopic black holes formed right after the Big Bang. Stephen Hawking proposed that these tiny primordial black holes could be scattered across the universe, holding the secret to dark matter. And recent research suggests they might have even carried color charge, a new state of matter. Curious to know more? Watch our full video to dive deeper into the mysteries of dark matter and the early universe.
Why does the Earth spin? Have you ever wondered why the Earth spins? This isn't just a cool phenomenon, it's a crucial part of how our universe was formed. About 4.5 billion years ago, our solar system began forming from a giant cloud of gas and dust. As this cloud collapsed under its own gravity, it started to spin. This spinning motion caused the planets, including Earth, to form and retain their angular momentum. And that's why the Earth spins. This is due to the law of physics known as the conservation of angular momentum. When an object in space starts spinning, it keeps spinning unless a force acts to slow it down. That's why Earth continues to spin day after day, never stopping. This spinning gives us day and night. As the Earth rotates, one half always faces the sun, creating daylight, while the other half faces away, resulting in nighttime. But that's not all. The Earth's rotation also affects our climate and weather. It creates the Coriolis effect, which influences how air and water move across the Earth's surface. This helps generate weather patterns, wind systems, and important ocean currents. Even more interesting, not all planets spin at the same speed. Earth takes about 24 hours to complete one rotation, while Mars takes 24.6 hours, and Venus takes a whopping 243 Earth days.
Facts about the Moon. 1. Largest relative to its planet, the Moon is the largest natural satellite in the solar system in relation to the size of its planet, Earth. It's about 1/4 the size of Earth. 2. Always shows the same face. The Moon is tidally locked to Earth, meaning the same side, the near side, always faces Earth, while the far side remains hidden. 3. Moonquakes. The Moon experiences moonquakes caused by tidal forces from Earth. These quakes can last much longer than earthquakes. 4. Lack of atmosphere. The Moon has almost no atmosphere, which means it doesn't have weather, wind, or protection from space radiation. 5. Formation theory. The leading theory of the Moon's formation is the giant impact hypothesis, suggesting it formed from debris after a Mars-sized object collided with Earth around 4.5 billion years ago. Hey, space enthusiasts, today we're diving deep into the heart of our galaxy, the Milky Way, to unravel a mind-bending cosmic mystery. Imagine a strange, high-energy blob hurtling around the supermassive black hole at the center of our galaxy at a staggering 30% of the speed of light. And this isn't just some random blob. It's emitting powerful radiation that reaches all the way to Earth every 76 minutes. Buckle up as we explore what's really going on around Sagittarius A, the Milky Way's supermassive black hole. Our journey starts in the most extreme environment in the Milky Way, a place where gravity is so intense that not even light can escape. We're talking about Sagittarius A, or Sagittarius A, the supermassive black hole at the center of our galaxy. Black holes like Sagittarius A are known for their intense gravitational pull, which creates a region called the event horizon, a point beyond which nothing escapes. But here's the thing. Black holes don't emit radiation themselves. So what's causing these mysterious gamma-ray pulses to reach Earth from this region every 76 minutes? The story begins with data collected by the Fermi Gamma-Ray Space Telescope between June and December of 2022. Scientists noticed something peculiar: high-energy pulses of gamma-ray radiation striking Earth from the direction of Sagittarius A in a rhythmic pattern, every 76.32 minutes, to be precise. Intriguing, right? But wait, why couldn't these gamma rays be coming from the black hole itself? Well, black holes can't emit light or radiation directly due to their event horizon. However, the environment around them, especially if it involves turbulent gas and dust, can. In active black holes, matter spirals inward, forming a hot, glowing disk known as an accretion disk. This disk emits light across the electromagnetic spectrum, from radio waves to high-energy gamma rays, as it gets torn apart by the black hole's immense gravity. But Sagittarius A is a bit different. It's not exactly the most active eater in the cosmos. In fact, it's more like a black hole on a starvation diet. So where are these powerful gamma rays coming from? This is where things get really interesting. Scientists analyzing the gamma ray data noticed a correlation, a periodical flare that seemed to occur in sync with X-ray emissions observed earlier. This clue led them to a groundbreaking hypothesis. Both the gamma rays and X-rays are being emitted by a blob of gas, spiraling around Sagittarius A at around 30% the speed of light. Think of it like a cosmic carousel, where this blob of matter is racing around Sagittarius A at 200 million miles per hour. As it speeds around, it flares up, emitting powerful gamma rays and X-rays periodically, like a lighthouse in space. But how does this blob manage to emit such intense radiation? The answer lies in the extreme conditions around Sagittarius A. As the blob spirals closer to the black hole, it encounters intense gravitational forces and magnetic fields, causing it to heat up and emit radiation across multiple wavelengths. This radiation then travels through space, reaching Earth after tens of thousands of years. And because gamma rays have such high energy, they're not easily absorbed by interstellar dust or gas. That's why we can detect them here on Earth. So why is this discovery so significant? For one, it gives us a new way to understand the environments around black holes, especially those like Sagittarius A that aren't actively feeding. It also sheds light on the behavior of matter under extreme gravitational and magnetic forces, which could help us understand the fundamental laws of physics better. Moreover, studying these periodic flares could help scientists predict other cosmic events and perhaps even discover new phenomena that we haven't even thought of yet. Moving forward, researchers plan to use even more advanced telescopes and instruments, like the James Webb Space Telescope, to study Sagittarius A and its mysterious companion in more detail. Who knows what other cosmic secrets we'll uncover in the future? Could there be more such blobs orbiting other supermassive black holes, emitting mysterious radiation? The universe is vast, and its mysteries are endless. And that's a wrap on today's cosmic journey. If you're fascinated by black holes, gamma rays, and the strange phenomena lurking in the universe, make sure to like this video, subscribe to our channel, and hit that notification bell. Stay tuned for more mind-blowing discoveries that take you to the very edge of space and time. Until next time, keep exploring the cosmos. The origins of the asteroid that killed the dinosaurs, a 66 million year mystery unraveled. 66 million years ago, Earth had what could be called the worst day in its history. An enormous asteroid, traveling at a speed of several kilometers per second, slammed into what is now the Yucatan Peninsula in Mexico. The collision was so powerful that it released energy equivalent to 100 million nuclear bombs. The impact left a 200-kilometer wide and 20-kilometer deep crater known today as Chicxulub, triggering a global cataclysm. The immediate aftermath was devastating. The impact generated colossal earthquakes and towering tsunamis. Firestorms raged across continents, setting vast areas ablaze. But that was only the beginning. The impact ejected immense plumes of soot, ash, and vaporized rock into the atmosphere. These planet-smothering clouds blocked sunlight for years, causing a drastic drop in global temperatures. Photosynthesis ground to a halt, and food chains collapsed. Over 75% of all species, including the mighty dinosaurs, were wiped out. The world became a wasteland, but from this destruction, new life would eventually emerge. For centuries, the cause of this mass extinction remained a mystery. Then, in the late 20th century, a breakthrough came from an unlikely source, a thin layer of clay found in 66 million-year-old rocks around the globe. Physicist Walter Alvarez and his colleagues noticed something peculiar. This layer was enriched with elements such as iridium, an element rare on Earth but abundant in asteroids and comets. The evidence pointed to a massive extraterrestrial impact. They connected this iridium-rich layer to the Chicxulub crater, naming it the Crater of Doom. The mystery seemed solved, but questions remained. Was the impactor an asteroid or a comet? And where did it come from in the vastness of space? Decades of research and debate followed. Some scientists suggested the impact could have been caused by a comet or even by massive volcanic eruptions spewing iridium from within Earth's mantle. But a groundbreaking study published in 2023 offers the most definitive answers yet. By measuring isotopes of ruthenium found in the debris of the impact, scientists have been able to pinpoint the source of the asteroid. Ruthenium, like iridium, is rare on Earth's surface, but common in extraterrestrial objects. The study shows that this ruthenium is not from volcanic activity, but from an asteroid, a specific type known as a carbonaceous asteroid. These asteroids, rich in carbon and organic compounds, originate from the outer regions of our solar system. Carbonaceous asteroids are relatively rare. They are thought to have formed beyond Jupiter before being hurled toward the inner solar system by the gravitational influences of the giant planets over 4.5 billion years ago. These asteroids are believed to have brought vital organic materials and water to early Earth, playing a key role in the development of life. Ironically, the very process that helped kickstart life may have also set the stage for the dinosaurs' demise. The study's lead author, Mario Fischer-Gode, and his team used a technique called multi-collector inductively coupled plasma mass spectrometry to analyze 7 different ruthenium isotopes from samples collected around the globe. By measuring these isotopes and comparing their ratios to those expected from cosmic processes, they were able to conclude that the impactor was indeed a carbonaceous asteroid. This discovery effectively rules out other theories, such as volcanic activity, providing the nail in the coffin for the asteroid hypothesis. The study also raises questions about future impacts. If a carbonaceous asteroid like Chicxulub could wreak such havoc, when might the next one strike? Scientists estimate that an impact of this magnitude occurs once every 250 to 500 million years. While the odds of another such event happening soon are low, continued vigilance is crucial. The new findings have stirred discussions in the scientific community. Steve Desch, an astrophysicist from Arizona State University, finds the evidence convincing. He notes that it aligns well with other geochemical studies of impact debris. Other experts, like Richard J. Walker from the University of Maryland, emphasize that while the conclusions are not entirely new, the precision of the isotopic measurements is groundbreaking, providing a more ironclad determination of the asteroid's origins. James Day from Scripps Institution of Oceanography highlights that these stellar nucleosynthetic variations in isotopes give us unique insights into how different parts of the solar system evolved during its early formation. The study also brings to light the complexities of tracing cosmic material across billions of years, from its formation in supernova explosions and star interiors to its journey through the solar system and eventual collision with Earth. Lead author Mario Fischer-Gode is optimistic about future research avenues. He suggests that examining additional isotopes from comets, lunar craters, and other sources could refine our understanding of the solar system's history and the events that have shaped Earth's biological evolution. The story of the Chicxulub impact is more than just a tale of destruction. It's a cosmic story that connects the origins of life to the death of the dinosaurs, demonstrating how events billions of years ago can shape the world we live in today. As we learn more about our universe, we uncover not just the history of our planet, but the intricate dance of celestial bodies that have written the fate of life on Earth. For more insights into the universe's greatest mysteries, subscribe and stay tuned.
The search for life, habitable planets beyond Earth, appearing on screen. Hello, space enthusiasts. Have you ever wondered if there are other planets out there that could support life, just like Earth? In today's video, we're diving deep into the fascinating world of exoplanets. Those mysterious planets orbiting stars beyond our solar system that scientists believe might just have the right conditions for life. Buckle up as we explore these distant worlds, the criteria for habitability, and the exciting possibilities they hold. Before we dive into specific planets, let's talk about what makes a planet habitable. The key factor is location, location, location. For a planet to support life as we know it, it needs to be in the habitable zone, also known as the Goldilocks zone, around its star. This is where temperatures are just right for liquid water to exist. But that's not all. A planet also needs to have a stable atmosphere with the right mix of gases, a rocky surface where life could potentially take root, and a magnetic field to protect it from harmful cosmic radiation. Now that we know what to look for, let's explore some of the most promising exoplanets discovered so far. Let's start our journey with some of the most exciting exoplanets that scientists believe could support life. First up, we have Proxima Centauri b. Proxima Centauri b is the closest known exoplanet to Earth, orbiting the star Proxima Centauri just 4.24 light-years away. This rocky planet lies within the habitable zone of its star, meaning it could potentially have liquid water on its surface. However, because it orbits a red dwarf star, Proxima Centauri b is subject to intense stellar flares, which could make the environment challenging for life as we know it. Next, we have the TRAPPIST-1 system, a fascinating star system with 7 Earth-sized planets, 3 of which are in the habitable zone. These planets have captivated scientists because of their potential to host life. Imagine an entire star system with multiple planets that could each have oceans, rivers, and maybe even life forms. And we can't forget about Kepler 186f and Kepler 452b, 2 Earth-sized exoplanets in their respective habitable zones. Kepler 186f was the first Earth-sized planet found in the habitable zone of its star, making it a milestone discovery. Kepler 452b, often called Earth's cousin, is larger than Earth and orbits a star similar to our Sun. This makes it a prime candidate for further study. However, not all that glitters is gold. Many of these exoplanets orbit red dwarf stars, which, while being the most common type of star in the Milky Way, are notorious for their powerful stellar flares. These flares can strip away a planet's atmosphere, leaving it barren and lifeless. Distance is another challenge. Even though some of these planets are relatively close in cosmic terms, they're still light years away from Earth, making it difficult to study them in detail. Current technology limits our ability to directly observe these planets, but advances in space telescopes like the James Webb Space Telescope could soon change that. Speaking of the James Webb Space Telescope, this groundbreaking instrument is set to revolutionize our understanding of the universe. With its advanced capabilities, we'll be able to study the atmospheres of these exoplanets in unprecedented detail, searching for signs of life, such as oxygen, methane, and other biosignatures. These future missions will help us determine whether any of these exoplanets could truly support life, or if we need to keep searching. As we push the boundaries of space exploration, the dream of finding life beyond Earth becomes more tangible with each new discovery. The big question on remains: are we alone in the universe? While we've found many planets that could potentially support life, we have yet to find definitive proof. But the search is far from over. Every new discovery brings us one step closer to answering this profound question. As we gaze up at the stars, it's incredible to think that there could be other worlds out there, teeming with life, just waiting to be discovered. The universe is vast, and the possibilities are endless. Thank you for joining us on this journey through the cosmos. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon to stay updated on all things space. Let us know in the comments which exoplanet you find most intriguing and what you think the future of space exploration holds. Until next time, keep looking up at the stars and wondering what lies beyond. See you in the next video.
The universe, an endless expanse that encompasses everything we know, from the smallest subatomic particles to the vast galaxies stretching across the cosmos. It's a place of infinite wonder and mystery, where space and time dance together in an ever-expanding cosmic symphony. The universe is everything. All of space and time, collectively referred to as space-time, along with their content. It includes every form of existence, every fundamental interaction, physical process, and constant. From the tiniest particles to entire galactic filaments, the universe contains all matter, energy, and the complex structures they form. According to the most widely accepted cosmological theory, known as the Big Bang, the universe began approximately 13.8 billion years ago. Space and time emerged together in a singular, explosive event. From that moment on, the universe has been expanding, stretching the very fabric of space-time as it grew. The observable universe, the part we can currently see, has a diameter of about 93 billion light-years. But beyond what we can observe, the full size of the universe remains one of its greatest mysteries, still unknown to us. Long before modern science, ancient Greek and Indian philosophers pondered the nature of the cosmos. Their early models often placed Earth at the center of the universe, a concept known as geocentrism. But as our understanding grew, so too did our models. The heliocentric model, placing the Sun at the center of our solar system, marked a significant shift. We now know that the Milky Way, our galaxy, contains hundreds of billions of stars, and the observable universe itself is home to hundreds of billions of galaxies. These galaxies form a vast foam-like structure, where clusters and superclusters are interconnected by cosmic filaments of dark matter and gas. In the early 20th century, groundbreaking discoveries revealed that the universe had a beginning and has been expanding ever since. The Big Bang Theory not only explains the universe's origin, but also describes how energy and matter became less dense as the universe grew. As the universe expanded, subatomic particles and simple atoms formed. Over time, these building blocks coalesced into stars, galaxies, and eventually, all the wonders we observe today. The cosmos as we know it is a direct result of this incredible journey, from a hot, dense beginning to the rich, complex structure of the universe we see now. The universe is not just a place. It's a story that continues to unfold with every new discovery we make. It's a reminder of how small we are, yet how deeply connected we are to the cosmos. From the beginning of time to the farthest reaches of space, the universe is our ultimate frontier, filled with endless possibilities and untold mystery. As we continue to explore and learn, we come closer to understanding our place in this vast expanse. The universe is more than just a collection of stars and galaxies. It's the story of existence itself. Thank you for joining us on this journey through the cosmos. If you enjoyed this video, don't forget to like, share, and subscribe for more explorations of the wonders of the universe.
Welcome back to our channel. Today, we're diving deep into a fascinating question. Is time travel possible? Let's explore what science has to say about this topic and uncover the mysteries surrounding it. Time has been a concept that has captivated humanity for centuries. In countless works of science fiction, from Doctor Who to Back to the Future, time travel is an essential element. But the real question is, can we actually make such journeys in real life? The short answer is yes, and you're doing it right now. That's right, we are all moving into the future at the rate of 1 second per second. Whether you're watching paint dry or wishing you had more time to visit a friend, we're all moving through time at the same speed. But this isn't the kind of time travel we usually think about when it comes to movies or books. In the realm of science fiction, we often see characters step into strange machines to travel to the past or the future. These journeys bring up questions like, what would happen if you change the past or use information from the future to alter the present? But how does this play out in reality? While many people are fascinated by the idea of changing the past or seeing the future before it happens, no one has ever demonstrated the back-and-forth time travel seen in science fiction, nor has anyone proposed a method for sending a person through significant periods of time that wouldn't destroy them along the way. As renowned physicist Stephen Hawking once said in his book, Black Holes and Baby Universes, the best evidence we have that time travel is not possible and never will be is that we have not been invaded by hordes of tourists from the future. However, science does support some amount of time bending. For example, according to Albert Einstein's theory of special relativity, time is an illusion that moves relative to an observer. An observer traveling close to the speed of light will experience time much more slowly than someone at rest. This is why astronaut Scott Kelly, who spent a year in orbit, aged slightly less than his twin brother, Mark Kelly, who stayed on Earth. GPS satellites, for example, have to adjust their time because of this difference. When satellites move at high speeds in space, their time moves slightly slower than time on Earth. To ensure precise positioning, engineers must calculate compensations for these differences. There are also other scientific theories about time travel, including ideas involving wormholes, black holes, and string theory. But for the most part, time travel remains the domain of science fiction books, movies, television shows, comics, and video games. Einstein's special relativity theory, developed in 1905, along with his later expansion into the general relativity theory, has become one of the cornerstones of modern physics. Special relativity describes the relationship between space and time for objects moving at constant speeds in a straight line. So, why is relativity important to the idea of time travel? First, all things are measured relative to something else, meaning there is no absolute frame of reference. Second, the speed of light is constant, no matter where it's measured from. And third, nothing can go faster than the speed of light. From these simple principles, real-life time travel unfolds. An observer moving at high velocity will experience time at a slower rate than someone not moving quickly through space. Although we can't accelerate humans to near light speed, we can send them around the Earth at 17,500 miles per hour, 28,160 kilometers per hour, aboard the International Space Station. This demonstrates that time can be bent and flows differently depending on an observer's speed and location. So, if you're thinking about time travel as a way to live longer or travel to the distant future, that's still a long way off. But effects like the slight time difference between GPS satellites and Earth show that these concepts can be crucial to modern technology and science. NASA also states that general relativity could provide scenarios that allow for backward time travel. But the physical reality of those methods isn't exactly easy. Wormholes are hypothetical tunnels through the fabric of space-time that could connect different moments or locations in reality. However, no wormholes of any kind have been identified in real life. Other theories, like astronomer Frank Tipler's Tipler cylinder, involve taking matter that is 10 times the sun's mass and rolling it into a very long, dense cylinder. When spinning this cylinder at billions of revolutions per minute, a spacecraft nearby could travel back in time on a closed time-like curve. However, the main problem is that for the Tipler cylinder to become a reality, it would need to be infinitely long or made of some unknown type of matter. Another idea is the time donut proposed by theoretical physicist Amos Ori. He suggested a model for a time machine made from curved space-time, a donut-shaped vacuum surrounded by a sphere of normal matter. But this, too, is purely hypothetical, because the ability to manipulate gravitational fields at will is still beyond our reach. So, while these theories open up many exciting ideas, the possibility of real-time travel remains a dream for a distant future. Thank you for watching this video. If you love exploring science like this, hit the like button and subscribe to our channel so you won't miss any of our exciting future videos.
What would happen if your warp drive spaceship flew into a black hole? Sounds like science fiction, right? Well, today, we dive into the latest research exploring just that scenario. Buckle up, because we're going beyond the limits of space and time. Warp drives, those iconic tools for faster-than-light travel, fascinated us for decades. Introduced by John Campbell in the novel Islands of Space and popularized by Star Trek, warp drives have become synonymous with exploring distant galaxies in the blink of an eye. But what is a warp drive really? Imagine a spacecraft encased in a bubble that can manipulate space-time, allowing it to travel faster than the speed of light. Sounds cool, right? Unfortunately, it's still just theoretical. Physics problem waiting to be solved. Recently, two researchers, Remo Garatini and Kirill Zatromailov, posed a daring question. What if a warp drive-equipped spaceship flew into a black hole? Their findings, published in Physics Letters B, push the boundaries of what we think is possible in physics. Black holes, regions in space where gravity is so strong, not even light can escape. The authors of the study specifically focused on Schwarzschild black holes, which are non-rotating and have no electric charge. They represent a clean slate for exploring new physics. By combining the mathematics of black holes with warp drives, Garatini and Zatromailov calculated what might happen when a warp bubble approaches a black hole. Here's where it gets really interesting. As the warp drive ship enters the black hole's outer region, the intense gravity would reduce the negative energy needed to sustain the warp bubble. If the ship's speed is lower than the speed of light, it might even eliminate the black hole's event horizon, letting the ship pass through unharmed. This could mean that instead of being crushed by the immense gravity, the warp bubble could safely navigate through, potentially even using the black hole as a shortcut to another part of the universe. So, what does this mean for us today? Well, while we're not yet ready to build starship-sized warp drives, this research could help scientists create mini warp drives in laboratory setting. The idea here is that in controlled conditions, a small-scale warp drive could be experimented with, understand the underlying physics, perhaps even leading to new breakthroughs in our understanding of space-time. Of course, there are still many hurdles to overcome. One of the biggest is the energy required. It's estimated that a warp drive would need an unfathomable amount of exotic matter, something we don't have and aren't even sure exists in the necessary form. Physicist Miguel Alcubierre, who first proposed a warp drive theory in 1994, pointed out that while the math works on paper, we're far from having the technology or understanding needed to make it a reality. The research also suggests that if a warp bubble is small and slow enough, it could even increase a black hole's entropy. But if the warp bubble is too big, it could erase the black hole's horizon, raising questions about our understanding of black hole thermodynamics. This research is a theoretical stepping stone that could lead to future advancements in warp technology. As we unravel more about quantum mechanics and the fabric of space-time, who knows what new discoveries await us. Imagine a future where we can send signals or images from inside a black hole, or use these objects to fuel our warp drives. The possibilities are mind-boggling. So, while warp drives remain in the realm of science fiction for now, research like this keeps pushing the boundaries of what's possible. Perhaps one day, warp drive technology will be as real as the devices we use today. What do you think about the idea of flying a warp drive into a black hole? Could it be the key to exploring the universe, or just another impossible dream? Let us know in the comments below. And if you enjoyed this dive into theoretical physics and space exploration, make sure to like, share, and subscribe for more cosmic content. Thanks for watching. Until next time, keep looking up at the stars.